Hello everyone, this video is about CO2 emissions from passenger vehicles. This graph can give you a rough estimate of emissions from different vehicles. I created it by combining lots of data from different studies and websites that I will mention in the video description. I must warn you that the whole video is an explanation of this graph, so it can be very boring, but you need it if you really want to use the information contained in the graph. I will discuss other more interesting aspects of transportation in other videos, but now let's focus on the graph. Before we start, I want to say that these numbers are not very precise. They're only meant to make comparisons. The units I use are grams of CO2 per passenger kilometer. So you can think about it like the amount of CO2 emitted by each vehicle while traveling 1 kilometer divided by the number of people inside the vehicle. The values that you see include the CO2 emitted during the construction phase, so you can call it a life cycle analysis. This is true for all the vehicles in the list apart from airplanes, because for them I didn't find enough data. However, I think the differences shouldn't be so big because planes emit most of their CO2 during their operation. So let's start from airplanes. Here, the higher value refers to trips shorter than 1000 kilometers, while the smaller value is for trips longer than 3000 kilometers. This can be explained by the fact that takeoff and landing are really CO2 consuming. So the more space is between landing and takeoff, the more efficient is the overall flight. Now let's move to cars. The ranges are so wide because it really depends on the efficiency of the vehicle and its size. We can see that diesel cars on average emit less than gasoline cars. I didn't include them in this graph, but I also have some information on LPG cars that emit a little more than diesel cars and natural gas cars, which emit a little less than diesel cars. Then we have electric cars. For an electric vehicle, the emissions can vary a lot, depending on the way you produce the electricity which you use to power the vehicle. So for battery electric vehicles, you can have a range between 65, which is a reasonable value if you use only renewable energies, to around 360, which is a value that you can obtain if you use electricity from coal power plant or oil power plants. If you consider the European electricity mix, the value would be around 200 grams per kilometer. This may sound like a lot for an electric vehicle, but you have to consider that some countries already have values much lower than that because they have lots of renewables. Then we have fuel cell electric vehicles, which are pretty similar to battery electric vehicles, but they emit a little more because the conversion process is not as efficient. That's why I'm not a big fan of fuel cell electric vehicles. Okay, so far we consider the cars to carry only one person, which is why the emissions per capita are so high. But if you consider average values, for example in Germany, the average emissions per person is around 100 grams of CO2 per kilometer. This means that Germans are pretty good at sharing cars, and they probably have efficient cars and kind of small cars. On the opposite, the American average is very high, it's around 200 grams per passenger kilometer, which can be explained because Americans use bigger cars, they have more gasoline cars than diesel cars, and probably they don't share as much. Obviously, one can do even better than Germany. If the occupancy of a car is 5 people, the emissions per capita can go down to less than 50 grams per kilometer. Now let's give a look at public transportation. For buses, here the small number refers to a full bus, while the big number is when only 10 people are in the bus. As you can see, even with such a low occupancy, using a bus is still better than using an empty car. For metro and train instead, I consider a fixed occupancy, a medium-high occupancy level. So the gap here is caused again by the different possible sources of electricity. However, notice that the best performance can be really good. And this is not science fiction. It really happens in some countries where there's lots of renewables. Finally, let's consider bicycles. As you can imagine, you don't need fuel to run your bike, but I still have to consider all the emissions during the manufacturing process, especially during the production of the metal frame. So the emissions per kilometer really depend on how many kilometers you use the bike for in its lifetime. So the small value here refers to a bike which was used for around 20,000 kilometers during its lifetime, which means you would basically have to use it almost every day for around 10 years. The big numbers refers to a bike which was only used 1000 kilometers during its entire life, which means basically you keep it in your garage. I also have some data on electric bicycles. Here the emissions are slightly higher because there's more manufacturing and because of course you use some electricity. I found also some information about other vehicles like scooters, but I'm not quite sure about it. It should be around 100 grams per kilometer. So it's better than an empty car, but it's worse than a car with 3 or 4 people. So I hope this information can help you to choose your means of transportation possibly. As I said, I will make more videos about this topic because knowing this data is not enough. It has been shown that even if there are alternatives to cars, people tend to use the cars more and more in the last years. And this is bad. This is a problem of our society and we need to try to solve it. So stay tuned and subscribe to the channel if you want to receive more information about this topic. Thank you.